Hello everyone. In this segment, we are going to talk about a new chapter. We are going to talk about functional dependency and normalization for relational database. So, in this chapter, this is chapter 15 in 6th edition. In this chapter, first we are going to talk about informal design guidelines for relation schema, functional dependency, normal forms based on primary keys, and a general definition of second and third normal form. So the main motivation behind this chapter is we are going to discuss about the quality of relational schema, or we are going to discuss of the goodness of relational schema. So what does that mean is that so far what we have talked about, um, uh, our chapter 1 to 2, it was about database architecture. Okay, and then chapter 3 we talked about relational model. Okay, so relational model. 4 and 5 was about SQL. All right, and then chapter 7 we just went over few steps back before the SQL, because we in chapter 7 and 8 it is about the conceptual model of database. All right, which we saw ER diagram. So in this step, actually what actually we did, we saw a basic database requirement. All right, a basic database requirement in just plain English word. Okay, basic database or basic software requirement, okay, in plain English word. And from that we learned how to design a conceptual model. Okay, conceptual model for a database. Okay, conceptual model for database, and the conceptual model we seen this is ER diagram. And then in chapter 9 we talked about how we can map this ER diagram into relational model. So into relational schema. Okay, how we map this ER diagram into relational schema. All right, so that relational schema and that relational schema, actually we can use the relational schema by we can run some SQL on that, and that we discussed in chapter 5, 4 and 5. So these are so far all we have went through in this database course. All right, so we learned about conceptual model, or we learned about implementation model. Okay, but now we are going to talk about at different levels how we can discuss the goodness of this relational schema. The goodness means how we can discuss the quality of the relational schema. So what I'm talking about, all right, so from if we think about like this is step 1, then ER diagram is step 2, and relational schema is step 3. Okay, so now after we got our relational schema, step 3, so our SQL running SQL depends on our relational schema. But how we can think about that, how good our relational schema design is, and when we talk about the quality of relational schema, how to actually qualify them. All right, so the main idea about the main motivation behind this chapter is we are going to talk about some informal guideline of database design, and then we're going to talk about some formal guideline of database design. Okay, so there are different approaches to database design. The first approach is bottom up, and the second approach is top down. So bottom up design, also known as design by synthesis. So what does that mean is, bottom up you can think about like, first we are going to consider all basic relationship of individual attributes. Okay, all individual attributes, then we are going to use them to construct relational schema. So each individual attribute means you can think about, like if you think about company database, so in company database has couple of tables and each table has attribute. But here we are not here actually we are not going to consider the table first. We are going to consider each and individual attribute first. For example, say employee name, employee SSN, okay, salary, like each of the individual attribute. Then we are going to, so each of the individual attribute, then we are going to think that okay, I can group this attribute together and maybe I can create a relation using all those attribute together. Okay, so the bottom up design start from each individual attribute. Okay, so they are the starting point. All right, and then we use them, and maybe we consider the group of attributes that we can consider them together and we can make a relation using that group of attributes. Okay, but a top down design is a different approach. It is known as by design by analysis. So that starts with a number of grouping of attributes into relation that exist together naturally. For example, I'm thinking about a company database. Now I can think about like I'm thinking about that my company database has okay, my company database has actually what is the main idea to store in the company database. I want to store like employee and their project. Okay, that is my main table that I want to store. All right, that is my main information that I want to store. Then I'm going to actually think about what should be all the attributes. Okay, group of attributes. Then I may think about whether I need to decompose one relation into multiple relation. Maybe I will decompose this employee project relation to actually two different relation, like say employee and project. Okay, so the top down approach is simply it will start with a number of grouping attributes into one relation or maybe a couple of relation that exist together naturally, and then we are going to analyze then we are going to do some analysis on those design, okay, individually or collectively. Then we are going to decide whether we need further decomposition until we find all desirable properties are met. Okay, so first we are going to talk about some informal design guidelines for relational schema. So some informal design guidelines for relational schema is here we are going to talk about actually 4 informal guidelines. So those guidelines are we are calling them informal because there is no mathematical formulation, but those guidelines are mostly based on intuition. What should be considered as the quality of the relational schema. So for the first informal guideline is we want to make sure that attribute semantics are clear. All right. So the idea is that when we are going to make a relational schema, all right, each of the relation or each of the semantic of the relation should be clear. For example, say in our company database we have a employee table. Okay, we have a project table. Okay, so based on the company database requirement, we want to keep track of employee table. We want to keep track of each employee, and we also want to keep track of each project, or we also want to keep track of which employee works on which project. So looking at the relational model, looking at the relational schema, it should be clear, okay, what is the real semantics, means the attribute semantics should be clear. Okay, the second informal guideline is that we want to reduce the redundant information in tuples. So reducing redundant information is very important. First of all, it will reduce the wastage of space. All right. And also, if we have multiple if we are going to store the same information in multiple places, that can create anomaly. All right. So for example, if you have like employee name, okay, in employee table, okay, and also the same information if you have in, say, in different tables, say project table, okay, say you are in the project table, you are storing that which employee works in which project, okay, L name and piano. All right. So in this table you are storing that which employee which employee works on which project. So if you store the same information in different table, that is going to take a lot of space, additional space, obviously, and also that can create anomaly, okay, different type of anomaly, and we are going to see couple of example. All right. And we do not want any type of anomaly in our database, okay. So saving same information in multiple places is not actually a desirable criteria in our database. We want to reduce null values in tuple. So as we talked about, the meaning of null can be different in database. So obviously in some places we are going to need null, but we are going to need null value, but the null value can have different meanings, okay. So it can have a meaning like missing. So null could mean like missing information, all right, or it could have also meaning unknown. All right. And also, if you have null in one of the attribute, okay, it's not possible to do any aggregate operation, aggregate function with that attributes, okay. Now that's why we want to reduce null values in tuple. Obviously in some cases we need null values, but we are going to try to reduce as much as possible, okay. We want to disallow possibility of generating spurious tuple. So spurious tuple means some wrong tuple, uh, some spurious tuple means like it can be treated like as a misinformation, okay. Now there could be possibility if in various reason, okay, if it can create spurious tuple or for wrong tuple for some join operation, okay, for some join operation, aggregate function, or running some type of operation. In that case we should be careful about that, okay. We do not allow any kind of possibility that can generate spurious or wrong tuples, okay, or misinformation.